Hi there, I'm Jeremy Krug, and I'm going to work free response question number 7 on the 2023 AP Chemistry exam. This is a short problem, and it's worth a total of 4 points out of the total 46 on the free response section. Just so you know, I'm recording this video on May the 3rd, 2023, and the official answer key has not been released yet, so I'm doing my best to share what I think the correct answers are. Just a disclaimer, I do not work for College Board. I'm just a chemistry teacher who's been teaching AP for 23 years, and sometimes I make a mistake. And remember that any answer that is chemically and factually correct will be accepted by the AP readers, even if it doesn't match what's on their key. So with that in mind, here's question 7.
Question 7 starts out with strontium hydroxide being dissociated and dissolved here in solution. And here we have another particulate diagram. We've actually seen several of these on this FRQ exam this year. And this seems to be the last one. We have a student drawing a particulate diagram shown to represent the ions. The strontium, or these dark circles, and the hydroxide are supposed to be these little things here with the O and the H. Of course, water's not there. Identify the error. Well, if you're taking a look at the stoichiometry here, you notice that for every one strontium ion, you should have 2 hydroxide ions. And the student has drawn 4 strontium ions, but has not drawn the corresponding 8 hydroxide ions. And so I would say that the student has left out 4 hydroxide ions. There should be 8 hydroxide ions drawn. Or I guess if you want to go in the opposite direction, you could say that there should only be 2 strontiums for the 4 hydroxides. Either way, you want to say something that there should be 2 hydroxides for every 1 strontium drawn in the box. So something along those lines. If you got that, then give yourself a point. On part B, 1 here, we have a saturated solution. And it says that in the solution, the student determines that the strontium ion has a concentration of 0.043 moles per liter. And the question says calculate the value of hydroxide. So this is just a simple stoichiometry. We have 0.043 molar strontium, and we can just set up a mole ratio. So strontium goes on the bottom, hydroxide goes on the top. And from the balanced equation, it's a pretty simple ratio here, just a 2 to 1. 2 hydroxides for every 1 strontium ion. And so just multiply that by 2, and we get that the strontium, or the hydroxide ion concentration should be 0.086 moles per liter hydroxide. Now, part B2 goes a step further and says, okay, calculate the KSP. And it's kind of nice because they usually don't do this, but this time they actually gave us the expression for KSP. Sometimes that's something that they would expect you to write. This time they actually gave it to you. So all you have to do is plug and chug. The strontium is given to us. It's the 0.043 moles per liter. And we just calculated the hydroxide to be 0.086. Now that's going to be squared, just like it shows up here. So when you calculate that, the KSP is about 3.2 times 10 to the negative 4th. So if you got that, then give yourself another point. That's the 3rd point of the 4 here. The last question, part C, is about a second saturated solution of strontium hydroxide. But this time, instead of using distilled water, we already have 0.10 molar strontium nitrate in there. And so the question is the value of hydroxide ion concentration in this new saturated solution going to be greater than, less than, or equal to the value in the first saturated solution? And you need to justify it, and of course we're assuming constant temperature. So this is a good example of the common ion effect. The way that you might want to describe this is probably in terms of Q and K. Now, the value of hydroxide is going to be less than it was in the first solution. Now, the problem says that it's saturated, so that means Q equals K. And so when you increase the value of the strontium ions, the value of hydroxide has to go down in order to maintain that Q equal to K. So graphically, if you want to look at this, if the strontium is going up because you've got whatever was there in addition to the 0.10 molar. Well, that means that the hydroxide concentration has to go down in order to keep your Q value the same as it was before. So if you got that answer, then give yourself 1 point for that. And that's the 4 points here on the last question of this year's 2023 AP Chemistry Free Response section.
And that is question 7. How many of those 4 points did you get? There were some tough ones on there. If you haven't subscribed yet, I hope you consider hitting that subscribe button so you won't miss a thing on my channel for everything AP Chemistry. Thanks for watching, and I hope to see you again soon.